All right, so we're back. We're looking at, again, our electron configuration. Our electron configurations, we kind of talk about writing it in 4 different ways. So let's remember first our electron configuration, just the simple writing of our electron configuration. If I look at neon here, neon is element number 10. So if I just had neon atom, would have 10 electrons as well as 10 protons. So 10 electrons, I would write first 1s, the first energy level, s orbital, 2 electrons. Then I would go 2s, second energy level, s orbital, 2 electrons. That's 2, 4. I've got 6 electrons left. Fortunately, my 2p, right, second energy level, p orbitals. P orbitals, right, we can fit 6 electrons into that, and I have 6 electrons left. So this would be my electron configuration for my neon atom. The next one here, potassium. Potassium is element number 19. So if I had a potassium atom, right, it would be 19 protons, and then I would have 19 electrons. So 19 electrons, I'm going to start 1s2, 2s2, 2p6. I know that I got to go at least that high. So the first energy level, s orbital, 2 electrons. Second energy level, s orbital, 2 electrons. Second energy level, p orbital, 6 electrons. Then I get to go up to the 3s. The 3s, right, third energy level, s orbital, can again fit 2 electrons. I'm up to 12 now. Then let's go over to the 3p. The 3p, right, my third energy level, p orbital, I can fit 6 electrons again, and I have 1 electron left. Right, now, if I remember my orbital filling, right, if I come down here, right, the next block that I hit is the 4s. I don't go to the 3d yet. I go to the 4s first. So I go up here. I'm going to have my fourth energy level, s orbital, and I'm going to have 1 electron. Okay? See if you can fill in carbon. Now, let's look at our orbital notation for the elements, right? So our orbital notation, let's look at silicon here. Silicon, if I look at silicon, has 14 protons. So 14 protons means that I would have 14 electrons in a silicon atom. So I'm going to draw my 1s here, then I'm going to draw my 2s, then I have my 2p, which has, of course, 3 orbitals within it, right? So these are my 2p. Then I'm going to draw my 3s, and then I'll put my 3p here as well. Again, my 3p has 3 orbitals in it. So in my 1s, I'm going to draw an up and a down. There's my 2 electrons there. I've got 12 electrons left. Then my 2s, I'll go up and down. I would have 10 electrons left. Now let's go into my 2p. Of course, Hund's rule tells me that I fill across with 1 up arrow first, and then I fill in down, 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 right? So I've got 4 electrons left, so I can put my 2 electrons in my s orbital. Now I have 2 electrons left, so I go over to my 3p, and I'm going to go up and up, right? So let's do the same thing with our oxygen. Oxygen, right, I've got 8 protons, so 8 protons would mean that I have 8 electrons. So let's draw my 1s, then I'll draw my 2s, and I'm going to put my 2p on here. My 2p, of course, has 3 orbitals, so now I have 8 electrons to put in here. 1, 2, 3, 4, right? Each arrow represents an electron. Then I have, that's 4, I have 4 electrons left. So I'm going to put 1 electron into each orbital. And then I'm going to add 1 more electron to finish my 8. Okay, so oxygen here would have 2 unpaired electrons and 2 paired electrons in our 2p orbital. Okay, so see if you can do lithium here now. All right, the third part for our electron configurations is to write an abbreviated electron configuration. Okay, we use our noble gases. So let's look at calcium here first. Calcium, if I look, calcium has 20 protons, right? So 20 protons, if I had a calcium atom, I would have 20 electrons. But writing 20 electrons out, I'm going to write 1s2, 2s2, 2p6, 3s2, 3p6, and then finally the 4s2. There's my 20 electrons. But if I go look at calcium, just before calcium, right, 2 elements before is argon. Argon has 18 protons, which would mean 18 electrons. So I'm going to write this is calcium there. Now I'm going to look at argon. Argon, we said, has 18 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6. Now I can see everything right here is the exact same, right? Everything up to the 3p6 for calcium is the exact same as argon. So my abbreviated electron configuration, I use my noble gases, right, which are right over there. Okay, I'm going to use my noble gases, and I'm going to say calcium's electron configuration is equal to argon in brackets, and then I can add my 4s2 electrons on top of it. So the argon in brackets tells me that this whole thing is in there. But all of those 18 electrons, I'm just not going to write them. I can write it much more abbreviated just using this argon, okay? So now let's do the same idea with aluminum, okay? With aluminum, right, aluminum has 13 protons. 13 protons, aluminum atom, that would mean 13 electrons. So looking at aluminum, I'm going to go backwards, right? So if I go backwards, I jump over magnesium and sodium, and I'm finally going to come over here and I'm going to hit neon, okay? So my aluminum electron configuration, my abbreviated electron configuration, I can write as neon in brackets. After neon, right, neon has 10 electrons, so that's going to take everything up to through the 2p6, okay? Then I'm going to have to write my 3s and then a 4p1. So 3s2, 4p1. Whoops, I screwed up. 3p1, okay? So if we know that in the third period here, we're filling in the 3s first, right? I can go say that I have my neon configuration, and then I can add the 3s2 and the 3p1 right there, okay? So, give you 2 more to fill in on your own. We can try chromium, which is Cr. Whoops, you can't see it down there, so I'll write it up here. So try Cr, and then we should also try Sn, tin, okay? See if you can fill in the abbreviated electron configuration for those. Again, remember that you go back first, find the noble gas, and then we start adding our extra electrons on top, okay?